Hello everybody. Today we are going to try to do a LeetCode programming problem live of medium difficulty. Uh, I was actually suggested a problem by a couple of people that I should try to solve and show how I would solve it. And I think it was this problem called letter combinations of a phone number. So let's try that out. Okay. So the problem description, let's read it out. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. Okay, so a mapping of digits to letters is just like the telephone buttons. It's given here, and note that one does not map to any letters. Yep, I guess 0 also doesn't map to any. Well, it maps to a space, but in our problem, we are only supposed to consider 2 to 9. For example, if the input string name digits is 2, 3, then since 2 maps to ABC and 3 maps to DEF, these are the strings that it could possibly represent. And similarly, I mean, this is an edge case example, and yeah, they don't have examples of length more than 3 and more than 2. But we are supposed to handle it. Well, actually looks like we are supposed to handle for lengths up to 4. Okay, and all the digits are in range 2 to 9. Those are the constraints that they have given to us. I mean, the approach here is algorithm, or at least the high level algorithm is very straightforward. We basically have to try every letter of one digit with every letter of second digit with every letter of third digit if there was one, and so on. So basically it's a Cartesian product of all the possible values for digit 1 times all the possible values of digit 2 times all the possible values of digit 3, and so on. They have given that the length is maximum 4 of the input string, but our approach that we take is not going to, at least theoretically, be limited to 4 length. It can go for more than 4. We will discuss why beyond a certain reasonable length of the string, the program might take too long to finish, but the code itself should theoretically be fine. So yeah, with that, I think we are ready to jump into figuring out how to translate that high-level algorithm into code. Now, right off the bat, I can see that we need a few things to get our code, right and elegant. The one thing we need is, okay, given a specific digit, what are the mapped letters to that digit, and store it in some data structure where we can basically look up very quickly by the digit the corresponding list of characters. I mean, since this is a very narrow range of 2 to 9, the easiest thing that comes to my mind is to do in Java like what's called a final static final variable, because this we need it once for the whole program and doesn't change. So something like this, digit to chars. I'm following the naming convention in Java, I believe, for static final is to use all caps and use underscores to separate the separate different words. So anyway, so I think what I'm also going to do is I'm going to basically keep 0 and 1 just empty, because that just is allows us to not have index adjustment, and we can directly index with the sorry, not caps, we can directly index with the digit itself. I'm just going to quickly write this out. GHI is for 4, GKL 5, MNO 6, PQRS is 7, TUV 8, WXYZ is 9. Okay, so that's kind of where we can take a digit, like for example 2, go and index 2 of this array, and it will give us a string which has all the characters that are mapped to that particular digit. Okay, so that's one piece of thing we need. Now the most crucial piece of the thing that we need to figure out in this code is how to do this Cartesian product of multiple digits, right? So hey, you loop over all the possible characters mapped to, for example, letter 2, but for then each of them loop over all the possible mappings of the next digit, and for each of those loop over more digits and so on. Now if it was just given that there was only 2, then we could write 2 nested for loops, like for example in the case of this special case of length 2, you could take you could write 2 nested for loops. The outside for loop determines what we want to map 2 to, for example A. The inside for loop says what we want to map 3 to, for example D. And then for each of those we just kind of add it to a resultant list. But the problem is it's not limited to 2 digits. The problem does say it's limited to 4 digits, so we could write 4 nested for loops, 3 nested for loops, 2 nested for loops for different lengths of the input string, but as you can see that gets very clumsy and error prone. So I think for such cases where the number of nested loops is variable or dependent upon some input, either the length of the input or something else, a very common approach to take is do recursion. Like just write a loop in the recursive function which is looping over a specific digit, for example, and then inside the loop we are calling recursively for the next digit, and then that recursion call can call further recursion if there is more digits. So hopefully that makes sense, and the base case in that case is okay, you have kind of determined various values or mappings for each of the digits and everything is done. So you have a full combination. For example, you have determined that 2 maps to A, and for that you have determined that 3 maps to F, and then you say okay, here I have a full string or a full result, and then you add it to some list. So the rest of the code is going to be about writing this recursion elegantly, passing in the information we need, returning the information we need if needed, and so on. So let's do it. Now, such a recursive call, we need to figure out a few things. One is that, I think we need 2 things. One is that, okay, where are we going to construct the whole string? The string of A, D, or BE and stuff like that, or where do we construct that string? And I think given how we are going to structure our recursion, we just need a simple array of whose length we know in advance, because the length of the array would be the same as the length of digits string, and we are going to have index into that array where that recursive call is working on. So let me write it out. I think you will understand, and you will also understand very quickly why this is a void return type. So let's say letter combinations recursive. I mean, the name could be better, but for now I'm going to use that name. Since there are going to be a few parameters to this function, I'm going to write them out a little bit in some logical grouped fashion. Let me create more space here. Okay. So the first thing we are going to pass here is, of course, the digits string. But then, like I said earlier, each call to this recursive function is working on a specific digit, and so digits index will be will indicate what digit are we working on, and the job of each recursive call is do all the various mappings for that digit. The next thing we need is a character array, which is actually a result, a specific result, which means a specific mapping, right? So BD would be stored in result, for example, ultimately when it is fully constructed. And then of course the index into that as well. And then the final thing we need is the full list where we are going to add all the results. Once we have completely constructed a specific result, we are going to add it to this. So once the recursion is fully done, this will contain the full list. Okay, let's now let's first now figure out the base case. So the base case, like I said earlier, is imagine this example where the input is 2, 3. So the first recursive call to this function is job is to figure out what are all the letters that map to 2 and loop through them, and then call another recursion call for the next digit. At some point will come to an end. Like if there are 3 digits, 2, 3, 4, 2 will loop through all the ABC, all the mappings of 2, and then call another recursive call for, say, iterating through all the mappings of 3. And then 3 will actually call for 4, but then 4 will actually call for empty. And so that's our base case. Okay, hey, when we are done with the digits, that means if digits index is equals digits dot length, then that means we have gone through all the digits and figured out a letter that maps to that digit, and hence we have a full result in the result array. So we are going to say results dot add, and I believe there is a string dot value of method which takes a character array in Java and converts it to a string. So yeah, we'll figure it out soon if that is not true. And remember, at this point we are done actually, which means in the base case we don't want to call recursively anymore. We are done. We basically found one valid result and we added it to the results list. Okay, so that's our base case. Now if it is not in the base case, the first thing we need to figure out is, hey, what is the digit we are at, right? And that would be ch digit. Digit in the form of a character would be digits dot char at digits index. Basically, so the index is given to us and that's the digit we are operating on. Now we want to probably do some error checks. The video might become a bit long, but let me just demonstrate how I would do error check here. We do want to make sure, even though the problem states that you can assume that, I think that this is actually a digit. So I believe either there is a static method in the character class. Yeah. And if that is the case, then we can throw some exception which indicates that this isn't allowed. Invalid digit or invalid character rather. Yeah. Okay. And then once we are done with that, we know it's a digit. So let's convert it to a digit. And that would be int digit equals, I believe there is a method in character dot get numeric value, I believe, and that also takes ch digit or the character, and that gives us the digit. We also want to make sure, even though we are given to assume that it should be between 2 and 9, we can always add an error check there as well. I'm not bothering with error messages being super clear at this point, but just demonstrating what all we can do. And now that we have the digit, remember what we said is the characters mapped to these digits are already stored in this static array. So add that index. So we are just going to do that index and do index with digit, and that gives us all the characters which are mapped to that. And now we'll write a for loop to iterate to each of those possible values. and oh, sorry about that. There you go. Okay. And we just say char ch equals digit chars dot get, sorry, caret I. So that's the mapped character, and we want to store that mapped character in the result array at that position. So let's do that. Result index equals, I could have actually directly done this, but this keeps it a little bit more clear, so let me keep it that way. Okay, so we did that, but remember, after setting that character at that index in the result, we have to make the recursive call for the next one, and that has to be inside the loop so that we do a Cartesian product. So let's call our function recursively here. And okay, so the digits remain the same. The digit index will be one more because we are already working on the digits index, on the current digit index, and we want the recursive call to work on the next one. Result is the same, but result index will be one more than the current one because this current one is our location to store different characters mapped to this digit, and the result stays the same, that list. It's a reference to a list where we are storing all the values, all the results. Okay, I think that should be good. It is iterating through all the map characters, and for each of them it's calling, and then we have a base case where once we have exhausted figuring out all the digits, we have a full result in result, and we basically convert it to a string and add it. If there are some Java syntax issues, we'll fix them as we compile them. Okay, now we have to write the wrapper function. So for the wrapper function, we need a list of string, which is results equal to new array list is a great default list in most circumstances. So we do results equal to new array list of string. That's our results. We need one character array to and remember that is of the same length as the digits. Okay, and this is where we are going to just use one character array, and it will circle through all the possible results and add them as string into this. So this is a pretty memory efficient way of doing it, and we just make the recursive call with digits. We start at the 0th digit because we have to start somewhere, and we do result, and we start that at 0 as well because the first digit, or the 0th digit rather, its mapping has to be stored in the result array at 0th location, and then we just pass this, and once it is done, we return results. I do want to run through this one example manually through this code, so let's do that. Maybe let's run the 2-3 example manually. That's a pretty general case. Okay, so if digits was 2-3, we would allocate a new array, new list, which will be empty. We will allocate a new array which contains again like some default characters, which to us is gibberish, but we'll fill that up with valid characters, and then we just call the recursion. We start at 0th index at in both digits and results, and we pass an empty list here. So here, first thing we do is we try to figure out if we have reached the end of the digit string, and we haven't. We are at 0th index. So we say, okay, hey, what is the digit in character format? And that is in single quote 2 here. And then we say character dot is digit. Again, if these are not the right methods in Java, we'll fix them soon, but it says is it digit, it is, and we are going to get the numeric value of that into an integer so that we can index, and then it is between 2 and 9, and we are going to index into index 2 of this array, which is 0, 1, 2, ABC. So we get a digit chars is ABC, and here we get A, and then put that in the array at that index, and then call recursively for +1. And remember, we are still in the loop, so there will be a bunch of recursion calls, as many as there are mapped characters to this digit. Okay, digits index plus 1, so that's now 1. The result index plus 1 is also 1, and we make another call. We are still not at the end because length is 2, we are 1, and digits index is 1. Character at that is 3 here, and once we look that up, we get a numeric value of it, which will be 3, and then we look up index 3 here, which will tell us DEF. And then we loop through DEF one by one. CH is going to be D. For the first iteration of the loop, we put D in the second index, or I mean index 1, which is index 1 of result array. So already result index 0 of result array contains A, and now we put D. So we have AD in the result array, and then we call recursively again. And now we with plus 1 for each of these, and now we reach the length of the digits string, and so we say, okay, we have a full result. We are going to add it to the results list, and then we are going to short circuit return. I will go back to the recursion call for 3, which will now put, will go back and it will now put E in the same index. So now it becomes A and E, and then it will actually make another recursive call. It will be at the end, and it will add AE to the result. And so yeah, I think this should work. The only thing I want to check is that one example that caught my eye is if it is an empty string, it has to return an empty array, or an empty list rather. Let's make sure that works, because I have a feeling that we need a special case for that. So okay, so if we are given an empty string digits, we will allocate a new list. It is empty right now. We will allocate an array, will go in with 0 0, and yeah, this is gonna be, this will add one empty string into the list, because what will happen is 0 0 is the base case, so it will directly hit the base case, but at that point it will get string.value of result, and it will add it to results, and that is going to be empty at this point, which is not in fact it is, yeah, it is empty. But if Java was initializing, yeah, it's an array of length 0, which is actually converted to an empty string. So we do need a special case here saying if digits dot length equals 0, then we just return results, and results at this point is already an empty list, and that should be good. Okay, I think I'm ready to compile and run. As I said, there might be some Java compilation errors because of syntax that I may not have remembered. Okay, digits. Oh, I need to give a data type for that, obviously. Okay, so that is very silly. I need to say string. It's an array of strings, and that's the data type. So runtime error, invalid character. Okay, so I didn't do some conversion correctly. So let's look at that. Runtime error is line 27. Yeah, I think the get numeric value is probably not working properly. So let me search up how to Java convert char to int. Yes, that's what I want. Convert char to int. Yeah, we don't want to assume ASCII encoding, otherwise we could do some minus tricks, but that's not. Oh, character dot get numeric value. Yeah, that's what I did. Character dot numeric value is C. Okay, so why did that not work? Is digit, ch digit, and then ch digit. Numeric value digit is greater or equal to 2 and lesser or equal to 9. It should be the case. Let me comment it out and see what happens, because let's see. If it is not, it will give us an error of looking up into that static array, but it looks like okay. Oh, wait. Digit is greater or equal to, oh, if not, so yeah. That was really silly. Yeah, this can happen if it is less than 2 or greater than 9. then we want to throw. A lot of you watching are probably like, what is this guy doing? But anyway, we figured it out. Okay, there you go. I think it's accepted. That's accepted. Let's try with the longer string by adding our own test case. I'm going to add one with 2, 3, 4, like I said earlier, and also add one with 4, 7, 4, 7. Let's see what this does. If we add anything longer than 4, then it will error out because of validation checks. It does that. Test input strings cannot be longer than 4. But anyway, yeah, there you go. So GP, GQ, GPGR, etc. as you would expect. And there's a bunch more. It does view more here, but it works. Okay. Let me see if I want to cover anything else for this. I think so the only other thing we should talk about is time complexity, right? What is the time complexity of this algorithm? So that is pretty straightforward, but let me go step by step as to the time complexity. So I'm going to add comments here about that. Actually, the place to add a comment would be the recursive function, because that's kind of where okay. So the time complexity is, imagine a digits string of length d. Okay, so if we had d digits, okay, then for each of those d, we could be, in the worst case, considering 4 characters or C characters. C characters where I'm going to use these vertical bar notation. Those are C characters is the maximum, well, C equal to maximum chars mapped to a digit, and D equals number of digits. Then based on how we have written the code, it will be like you will loop through C times C characters for the, sorry about that, C characters for the next one, and so on. How many times? You will do it D times. So that becomes C to the power of D. So it becomes C raised to D. And that is completely understandable, because you have actually that many results that you need to produce, C to the power of D. And so it is exponential in that sense, but there isn't any good way to really reduce that because you have that many results, unique results, that you do need to add to the results list, and you have to generate them. There is no way to magically generate 100 results in like one iteration, right? You have to try out different combinations. So okay, yeah, that is pretty much all about this problem. Hopefully this was helpful. A lot of the patterns we saw in how we organize the recursion do recur in other problems, which we might see in future problems. Bye bye. Have a nice day.